Hello viewers, I'm Kausalya. Today we are going to solve problems related with Millman's theorem. The problem is use Millman's theorem to determine the voltage across 50 ohm resistor in the network shown. So here this is the given circuit diagram and we are expected to calculate the voltage across this 50 ohm resistors. Right. So here we are just marking the terminals, right? I'll tell you here why we are going for marking terminals. So here the first thing is we need to calculate this voltage across this 50 ohm resistance. So here we are marking the terminals as A and B, right? So in the previously solved problems, the circuit is totally different, right? We will be having a voltage source in series with the resistance. But here the thing is different, right? Here we are having a voltage source and there is a resistor which is parallel to it. And apart from that, there are some more resistors are present here, right? So in this case, you see, here I am marking the referral points. So here this terminal is A and this terminal is B. Right, this is A and this is B here. Now, when you closely observe, you see what are all the resistors that are connected with A. So to the terminal A, 20 ohm resistor is connected, 10 ohm is connected and 50 ohm is connected. Right? Yes. Now, the other end of the resistors, we have to mark by some numbers. So here the other end of this 20 ohm is marked as 1 and this 10 ohm as 2 and this 50 ohm as 3. Right. So once this is done, okay, this is mainly done to have a clarity. That's it. So now we are going to calculate the voltages. Right. So the thing is, you see, first we are calculating, because depending upon the voltage sources our formula expands, right? So here we are having how many voltage sources? Only 2 voltage sources, right? So here in this case, again when you proceed, but how many resistors are connected to this terminal A? There are 3 resistors which are connected. So this problem is little bit different, right? So first write down the voltage VA1. So VA1 here is this terminal 1, right? This is connected with positive side of 60 voltage source, right? So here VA1 is 60 voltage, right? So what about the value of impedance? That is this Y1 is nothing but, admittance. It is 1 by 20. And the next thing is VA2, right? So here in this case, this terminal is connected with a negative polarity of 100 voltage source. Therefore, VA2 is minus 100 and the respective value of Y2 is 1 by 10. Again, when you look at VA3, you see here there are no voltage sources. Therefore, it is 0 and the value of Y3 is 1 by 50. Right. Now, the next thing is we have to write Millman's theorem. So, by Millman's theorem, since here we are having 3 values of Y, our formula expands like this. VA1 Y1, VA2 Y2 and VA3 Y3 divided by Y1 plus Y2 plus Y3. Right. Now just substitute the values here. And finally, when you substitute, we are ending up with the answer as minus 41.17 volt. So what is meant by this minus? We have to change the polarity. So here you see the polarity is A should be of negative polarity and B should be of positive polarity to have a positive voltage like this. Right. So finally we have calculated the voltage across this 50 ohm resistor. Now we will proceed with the next problem. So the problem is find the current through 5 ohm by applying the Millman's theorem. So here this is our given circuit diagram. We need to calculate the current that flows through this 5 ohm, right? So the first thing is we are going to mark the terminals. So here the terminals are marked as, okay, 0 dash, okay, O dash and O, right? So we need to calculate the current that flows through this 5 ohm, right? So again the same thing. So to this O dash, you see how many elements are connected? 3 resistors are getting connected, right? So to the other end of the resistor, just mark the terminals as 1, 2 and 3 respectively, right? Now we are going to write the formula. So as usual, since here 3 resistors are getting connected with this point, our formula expands like this, right? So here the thing is VO1, right? So here we are having O and here we are having 1, right? So the thing is, when you move like this, you see from here it is plus to minus, right? Therefore here it is minus 25 volt. Again when you move like this, it is again minus to plus. Therefore here it is plus 50. Therefore the net output is, the net value is 25 volt here, right? Now the next thing is VO2. So here VO2 is, okay, between this O and 2 we are having a 25 volt. Again it moves like this, plus to minus. So again this value of voltage is minus 25 volt. The next thing is VO3. So O and 3, they lies at the same node and therefore there is no voltage which is connected to it, right? So here it is 0 volt, right? Now the next thing is to find Y1, Y2 and Y3. So Y1 is nothing but 1 by 10 and Y2 is 1 by 2 and Y3 is 1 by 5 here. Therefore here we will be having our respective values of answers. The next thing is we are going to substitute it, right? So in this formula when you substitute, you see VO1 into Y1, VO2 into Y2 and VO3 into Y3 divided by Y1 plus Y2 plus Y3. So just substitute the values and finally the value of voltage is minus 12.5. Right. Again the thing is we have to reverse the polarity of O and O dash. That is the meaning of that. And the next thing is we are expected to calculate the current that flows through this 5 ohm, right? So here we have calculated the voltage across 5 ohm. Once the value of voltage is calculated, it is easy to calculate the value of current, right? So the current is given by V by R. So the value of this voltage is 12.5 divided by the value of R is 5, right? So once you substitute here, the answer is 2.5 amps, right? So the thing is, the key thing to be noted here is you must be familiar to write down this formula because this forms the base, right? And the next thing is, depending upon the polarity, you have to assign a plus and minus sign for the respective voltages. Once that is done, then everything is easy, right? Now we will proceed with next problem. The problem is, using Millman's theorem, find the voltage across 4 ohm and hence the current through it. Again we need to calculate the voltage and current across 5 ohm, current through 4 ohm resistor. So here this is the given circuit diagram, right? Here we are having a voltage source in series with resistance and here also the same. But here you see we are having a current source in parallel with the resistance. So the first step is we are going to convert this current source into an equivalent voltage source. So here once you redraw the circuit, here this is how our circuit is, right? So we have modified this current source into an equivalent voltage source with a series resistance. And this is our 4 ohm and this remains as such, right? Now again the thing is we are marking the terminals as O and O dash, right? So by formula, right, you see here we are having 3 voltage sources and those 3 are connected with this O. So while writing, this is our formula V01 Y1, V02 Y2 and V03 Y3 divided by Y1 plus Y2 plus Y3, right? So here we know the values, right? Here it is connected, that is, you see, it is directly connected to a voltage source, right? So when you proceed, you see it moves from plus to minus here. Therefore, here we are writing minus 5 into, right, minus 5 into 1 by 5 and here again minus 4 into 1 by 2 and minus 10 into 1 by 10 here. Right. So the thing is just substituting the values. That's it. And the value of y1, y2, y3, as we all know, 1 by 5, 1 by 2 and 1 by 10. So once you solve, finally here the value is minus 5 volt. Again, the voltage should be always positive. We should reverse the thing. Okay, that's it. And the value of R is 1 by y1 plus y2 plus y3. So here the answer is 1.25 ohms. So now we are going to replace this entire part, okay, this entire part by a single voltage source with a series resistance, and this 4 ohm will remain as such. So here once you modify, right, our circuit will look like this. And again the value of current is given by V by R, right. So the value of R is 1.25 and 4 ohm here. So the final answer is 0.953 amps. Therefore here the voltage across this 4 ohm resistor is 5 volt and the current flowing through that resistor is 0.953 amps here. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.